Now let's move on to Lewis symbol. So Lewis symbol provide a convenient way to keep track of valence electron. So this is very important when we're discussing covalent bond. So before we can discuss in detail of covalent bond, you should be able to draw Lewis structure or Lewis symbol first. So let us look at the video and we will discuss further on that.
Structures. When we draw these, we will represent an atom by its chemical symbol. Here's carbon. We then draw that atom's valence electrons as dots around the atom. Carbon is 1s2, 2s2, 2p2, so that's 4 electrons in the outermost shell, which you can also tell by counting over from the left.
Okay, so the first step to draw Lewis structure is by writing the chemical symbol of the particular element involved in the compound. So let's say we have carbon, and you know that the valence carbon is 2s2 and 2p2, which is 4. If you count from the left 1, 2, 3, 4, then you know that carbon will have 4 electrons in the valence shell. So all these elements in this same group will have 4 electrons at the outermost shell.
For carbon and other small atoms, we assume that there are 4 coordination sites that can accommodate electrons or bonds, because this is how carbon can fill its octet, or its outermost shell. When we draw the valence electrons, we put 1 in each coordination site first, before pairing them up. So carbon will look like this, not like this. Elements in the same group will have similar looking Lewis dot symbols because they have the same number of valence electrons. Now to draw a Lewis dot structure for a molecule, just draw each atom with all of its valence electrons. Unpaired electrons from 2 different atoms can come together to make covalent bonds. When that happens, instead of 2 dots, we make a line. This is a covalent bond which always contains 2 electrons. For our purposes here, we can assume that electrons need to be paired, so a good Lewis dot structure will have all the electrons either inside covalent bonds or in lone pairs. The number of valence electrons an atom has dictates how many bonds it tends to form. Carbon likes to make 4 bonds. Nitrogen, with 5 valence electrons, likes to have 3 bonds and 1 lone pair. Oxygen likes to have 2 bonds and 2 lone pairs. And fluorine likes to have 1 bond and 3 lone pairs. When 2 atoms have 1 covalent bond between them, we call that a sigma bond. But atoms can have double or even triple bonds. Look at carbon dioxide. After we make a sigma bond between the atoms, there are still unpaired electrons. If adjacent atoms each have unpaired electrons, they can become another covalent bond. The second covalent...
Right. So the first step is to write the chemical formula of that particular elements involved in the compound or in the molecule and write the valence electron for each. And if they're all octet, for example, carbon has 1, 2, 3, 4 times 2, 8 electrons in the valence, means octet, then the structure is good enough. As for hydrogen, it has achieved doublet, 1 and 2. So let's say if single bond is not enough,
make 4 bonds. Nitrogen, with 5 valence electrons, likes to have 3 bonds and 1 lone pair. Oxygen likes to have 2 bonds and 2 lone pairs. And fluorine likes to have 1 bond and 3 lone pairs. When 2 atoms have 1 covalent bond between them, we call that a sigma bond. But atoms can have double or even triple bonds. Look at carbon dioxide. After we make a sigma bond between the atoms, there are still unpaired electrons. If adjacent atoms each have unpaired electrons, they can become another covalent bond.
Okay, now we have pi bond or double bond. So in order for double bond, this compound to comply octet rule, you can see if it is just single bond, then the carbon is not octet. So pi bond has to be formed or double bond has to be formed. So you can see now the carbon has octet numbers of valence electron, as also oxygen at the left side and the right side.
Second covalent bond in a double bond is called a pi bond. The second and third bonds in a triple bond are also pi bonds. Single covalent bonds are the longest, double bonds are a little shorter, and triple bonds are shorter still.